mesh analysis. We only have like 10 minutes to work on this video, so we'll make it a quick one. The next time, the next video, I'll add more to it, put dependent sources maybe, make the problems bigger. Same thing we did with nodal analysis. Uh-oh, forget my medicine. Well, with nodal analysis, we were doing what? KCL, right? That vitamin pill is like the size of a pencil sharpener. Pencil, or whatever. Eraser, I mean, not sharpener. Like a huge one. Hard to swallow. So with nodal analysis, we did KCL. With mesh analysis, guess what? What are we going to do? KVL. All the example we did with KVL before was for a single loop. KVL says the algebraic sum of all the voltages in a closed loop is 0. That's what KVL. The algebraic sum of all the voltages in a closed loop is 0. And we did this before. The only difference, before it was only one single loop. Now notice we have more than one loop. There's one closed loop right there. There is one closed loop right here. And guess what? There's a third one if you want, to the outside. With KCL, notice we assign currents. Remember that? We start assigning currents any direction that you want. So let's go V1, V2, V3, V4, then we start assigning current. Well, this is the same thing. We're going to say, you know what? I'm not really sure how the current is going to travel in this loop. Algebraic sum of all the voltages. So I'm not sure which way. So let me assign the current is going to go this way. In any direction you want. So I'm going to make it this way. I'll call this I sub 2. So I assign current like this in each one. Well, if the current is traveling this way, if I make it traveling this way, it's going to mark that resistor, it's going to mark it plus to minus. That's the voltage I'm talking about here. The voltage, Ohm's law says V equals what? I times R. What's the current through that? I sub 1. That'll be what? 4 I sub 1. This one is a little bit tricky. That one here, notice, if I'm traveling this way, it's going to mark it what? Plus to minus. And that voltage here will be what? 5 times the current going that way. What's the current going that way? 5 I sub 2. I'm holding on that 2 ohm. If you define the voltage for the 2 ohm coming this way, plus to minus, like this, that means it's 2 times the current coming down. And what's the current coming down?
I sub 1 minus I sub 2.
Yes. Everyone see I sub 1 is going this way, I sub 2 is going that way in opposite direction. So this will be, I'll turn sideways, 2 times I sub 1 minus I sub 2. I don't know if you can read it upside, like sideways. So now if I do KVL for this end here, is going to be sum of the voltages in a closed loop is 0. As I said before, 90% of the circuits book, they use minus to plus as a positive. I'm strange. It doesn't really matter. For the math, it doesn't matter. I use minus to plus as a minus. So, I mean as a minus. So that's minus 5 plus 4 I sub 1 plus to minus, that's plus 2 times, we said I sub 1 minus I sub 2. And minus to plus, that's a minus 2 equals 0. That's one equation. I personally like mesh analysis better than nodal for one reason. The math is always easier. Because in mesh equations, or nodal analysis, you're always dividing by the resistor. So you're dealing with the fractions. You have to get rid of the fractions. This one, you don't have to do that. You're not going to see that. So you do the math, notice, 4 and 2, that's 6I sub 1, minus 2I sub 2 equals what? Is that a 7? I think it's a 7, when you move it to the right side. That's the first equation. And if we do KVL right here, let's begin from here. Doesn't matter where you start from, but that's, you going this way, that's plus to minus, plus 5I sub 2, plus the 1, keep coming, notice I'm traveling this way. It's going to make this what? Plus to minus, that's plus 2. This will be minus, because you're entering the minus end, 2 times I sub 1 minus I sub 2.
Can we do the whole loop, like the whole thing?
You can do the outside one if you want to. But since I only have 2 equations I only have 2 unknowns, how many equations do I need? 2. So I can use this one with that one if I want to. I can use this one with that one. I can use this with this. I need 2 of them. Notice, by the way, a lot of times you'll see me actually change that to a plus, here to a plus, but reverse that one. Right, I sub 2 minus I sub 1. Wouldn't that be the same thing? Because I look at it, I go, if I decide to do this as plus to minus, because I'm traveling this way, this will be plus to minus, and the value of this will be 2 times, what's the current going up now? I sub 2 minus I sub 1, right? So instead of minus 2 times I sub 1 minus I sub 2, you'll see me use plus 2 times I sub 2 minus I sub 1. Exactly the same thing. I just want to point that out because I have a habit sometimes of writing it that way. Either way is fine. So let's collect like terms. That's negative 2I sub 1 plus 2I sub 2 and 5 plus 7I sub 2. 1 and 2 is 3. Taken to the right side, is that negative 3? And that's my second equation. Again, I'm always hoping I collect the like terms correctly. I go to my calculator here. Clear all. Trying to see if I can go actually and change without having to exit. I don't know how to do it without exit the calculator, so I'll just go back, shut it off, and restart. I'm sure there's a quick way to get to it, I just don't know it.
It's basically like networking.
2 by 2. So the numbers are 6, negative 2, and 7 for the answer, and the other one, negative 2, 7, negative 3. Calculate. I sub 1 is equal to 43 over 38. And I sub 2 equals negative 2 over 19. And now if you want to find anything else, you just plug them in. I'll try a couple more. Remember with KCL here, with nodal analysis, when we find a voltage source, oh, that's good. That's a super node. With mesh analysis, a current source is really a good thing to have. You'll see that when we get to it. You like to have current sources when using this method because that eliminates one of the unknowns. You might not see it today, but maybe next time, I don't know. Let me make the circle a little bit bigger here. Another one now, different one. That's 7. One. Six. 2. Try to make it big so I can write inside it. 3. 1. And 2. Notice how many loops do you have? A closed loop. There's 1, there's 2, there's 3, there's 4. There's 4 of them actually. But if you assign current, again, you can assign them in any direction that you want. This is what? What's this current here? Let's call it what? I sub 1. I shouldn't really use capital letters, but I have a habit of, I don't pay attention to them. Capital, you'll see when we get to circuits 2, that means you're in complex mode, in phasor. But I already wrote I sub 1, I sub 2. It bothers me now. Everything in circuit has a significant. So when you see I'm in circuits 2, that means, oh, you're in phasor, you're not in time domain. Lowercase is time domain, uppercase is phasor, complex. Okay. So I'm going to do KVL right here. There's one loop. Can you see it? So we're going to be traveling down for this one when I do this. I'm going to be traveling down with this. So I was going to mark it plus 2 minus, like this. I'm coming. So let's do KVL here. Let's begin right here. Minus to plus is what? Negative 7. I'm coming down. That's plus to minus. So plus. What is the voltage right here? Ohm's law says the voltage is what? R times I. Or I times R. What is R here? 1. What's the current down?
I1 minus I2.
Yes. I sub 1 minus I sub 2. Notice I sub 1 is coming down, but I sub 2 is going up. So the difference between them is what's coming down. Continue traveling. This will be a plus to minus. That's what? Plus 6. Continue coming down. Plus to minus, that's plus the resistor, which is 2 times, what's the current down through that resistor?
I sub 1 minus I sub 3.
I sub 1 minus I sub 3. Everyone see that? I sub 1 down, I sub 3 up. Now let's clean it, and there's the first equation. 1 I sub 1 and 2, that's 3 I sub 1. Again, keep your eyes open on the math. We have what? Minus I sub 2 minus 2I sub 3 should equal to what? When you move the negative 7 plus 6 is what? Negative 1. You move it to the right side, becomes what? That's a 1. And that's our first equation. Now let's do KVL at this loop. Again, I'm going to travel this way. I'm going to mark this plus to minus. We're going to find out what that current coming down. I'm going to travel this way. I'm going to mark it plus to minus. You're going to tell me what's the current going this way. Continue going up. I'm going to mark this what? Plus to minus. tell me what the current going up there. Everyone see that? So let's begin with this one. Plus to minus, that's plus, right? The resistor's 2. What's the current coming down equal to?
I sub 2.
Just I sub 2. I'm coming this way. I'll mark the plus to minus. That's plus 3 times. What's the current to the left?
I sub 2 minus I sub 3.
Yes, I sub 2 minus I sub 3. Keep going. I'm going up. I marked it up. See it? Going up there. That's plus 1 times what? What's the current up?
I sub 2 minus I sub 1.
I sub 2 minus I sub 1. Now you might be saying, how come you didn't do the minus? Why don't you use this one? I could. And if I use that, it will be minus this one. Well, minus that and plus, oh no, minus this one. Well, minus this and plus that, isn't that the same thing? Notice if you put a minus in front of this, that's negative I sub 1 plus I sub 2. That's what this one's giving you. It's the same thing. So now we clean it. What do we have for I sub 1? Just negative 1? I sub 2, I get 2 and 3 and 1, that's 6. And what do we got for I sub 3? Negative 3 equals 0. And that's my second equation. One more, I can use this one, or I can use the outside. I'll use this one. KVL again. Here's I sub 3. I define it going this way, so I'm going to mark this plus to minus, and I'm going to need the current going that way. Plus to minus, I'm going to need the current coming this way. Plus to minus, I'm going to need the current going up there. So let's begin with the 6, negative 6. That's a minus 6 plus 3 times. I define the current going to the right. Notice I'm spinning this way. What is the current to the right?
I sub 3 minus I sub 2.
I sub 3 minus I sub 2. I define the current coming down here, so it's 1 times I sub 3 plus 2 times, what's the current going up there?
I sub 3 minus I sub 1.
I sub 3 minus I sub 1. Clean that. What do we have? Negative 2 I sub 1. That's the only I sub 1 I see. I sub 2, I see what? Negative 3 of them. And I sub 3, 6 of them. And all of that equals 6. How many equations by how many unknowns? 3 by 3. Turn my calculator on. And let's go to that. New one. 3, 3. Negative 1, negative 2, 1, negative 1, 6, negative 3, 0, negative 2, negative 3, 6, and 6. And give me the answer. And according to the calculator here we go. I sub 1 equals 3. I sub 2 equals 2. And I sub 3 equals 3. So we found the 3 currents going through that. Anything else you want to find about it now? We can find that. Now we did not do any dependent sources. We did not do any current sources in the circuit. So that's next video, next class. So we'll finish that next time. I'll stop the video now. We're out of time, and we'll add that piece next time.